For the second half, coming up now, would like to welcome Professor Robyn Lucas, who's from the National Centre for Epidemiology and Population Health, and will be sharing with us the evolution of vitamin D research. We get a lot of questions from people regarding the vitamin D, so we are very welcome to have you over here from Canberra and look forward to your presentation. Thank you.
Thanks, Sandra. So I'll give you a little bit of a background to me, as Alan did. So I'm a New Zealander. So I ring in over here. I trained in medicine in Auckland, worked in several countries, Canada and the Solomon Islands, and in Australia for a bit, and have been in Canberra for nearly 15 years, and then I was in Perth for a year last year at the Telethon Kids Institute, and I've now moved back to Canberra, but I'm still holding a honorary position at the Telethon Kids Institute and still doing quite a lot of work there. So my research has been, when I finished my PhD, I had a whole lot of years off with kids, and I came back and did a PhD, and when I finished that PhD, I went straight into running a big case control study, and I'll tell you more about that a bit later, on the East Coast, and it was specifically looking at risk factors for multiple sclerosis, and very specifically looking at vitamin D at the time, and then we've been looking a lot more at sun exposure as well. So what I want to do today is take you through the vitamin D story and show you really what a pivotal role Australian research has played in that story. And there's a really good reason why sun exposure and vitamin D research is better and stronger here in Australia, and probably particularly for WA. And that is because we have this huge latitude gradient, really a larger latitude gradient than just about any other country in the world. The US also has that big latitude gradient, but they have a strange healthcare system, which is, we have a nice homogeneous healthcare system across the country, so that you can compare the people that live right in the north with the people in Tasmania without a whole lot of sort of extraneous factors that might make it different in terms of the diagnosis of MS or the treatment of MS or anything like that. So Australia is really one of the best places in the world to do the sorts of research that we do. And of course, WA spans the whole latitude span pretty much of Australia. I talk quite a lot to MS audiences, and when I talk in the ACT, everybody knows me because I've been involved there for over 10 years. Please, if you've got a question or you don't understand something, don't leave it till the end because you will have forgotten it by then. So please just put your hand up and interrupt me, and we can go through it again, or I can answer a question. So when we think about, and Alan touched a little bit on this morning, so when we think about MS and vitamin D, or any risk factors actually for MS, we need to think about the things that affect the risk of actually getting MS. So first of all, Alan talked this morning about clinically isolated syndrome. So the very first indication that somebody might be at increased risk of getting MS, that very first neurological event like an optic neuritis or something like that. But then there are also the things that affect MS getting worse, and they may not be the same things. So we really need to look at risk factors and vitamin D in relation to risk of getting MS and the risk of the MS getting worse, so disease progression, more active disease. And then we also need to think about, in people with MS, can vitamin D and sun exposure affect just well-being, how you feel, comorbidities, the things that we talked about this morning with balance, that we'll talk about this afternoon with fatigue. All of those things may also, we need to look at the risk factors that may be different across those three things. And so we can look at them a bit separately. And my talk is a bit structured like that. So we'll look at vitamin D as a risk factor for MS, vitamin D in people who have MS in terms of disease progression, and then vitamin D in relation to other factors outside the disease. Ellen touched on many of my bits, including some of the same slides this morning. So the first hints that there was some association with sun exposure or vitamin D came from these studies. There was one in 1922 and then another one published in 1960. They looked at people who'd been, men in the US who had been drafted to fight in the world wars, and some of these men had gone on to develop MS, and they had looked back at where those people were born. And what they found was this is degrees away from the equator. So this is closer to the equator and further away from the equator. So in the US, of course, that's going north, whereas for us it'll be going south. And these are the number of people with MS per million in these different places. And what they found was the further you went from the equator, the higher was the prevalence, or MS was more common the further you went away from the equator. So this was the first sort of hint, but lots of things vary with latitude. You know, it gets colder as you go further south for us. Our diets are a bit different in Europe, and those high latitude countries in Europe, you know, a bit stodgier, different diet. You want to keep warm. In Canberra this week, be a lot of nice warm stews and soups. But there are a lot of infections are different as well. So what this guy Aitchison did, who published this paper, is he looked at latitude, but he also looked at levels of ultraviolet radiation. And there was an even stronger correlation with levels of ultraviolet radiation than there was with latitude or temperature or anything else. So this was a clue that there was something happening linked to sun exposure. This is UV around the world, so it's January, so it's summer in the southern hemisphere, and you can see as you move away from the equator, that's 0, the UV levels get lower. You can see across Australia, very high UV in January in the north, and then as you get down here to Tasmania, there's much lower UV. So this is just how UV varies across the world. This is the picture that Alan also showed this morning. So these are data from 1981. They're published in 1994. And you can see that the prevalence, so this is the number of people with MS per 100,000 of the population, so just people with MS. Up there in far north Queensland, it's 11. Down in Tasmania, it's 75, so about a 7-fold increase down the east coast. And it's not just a difference between far north Queensland and Hobart, it's actually a sort of a graded difference. So you could plot this out and it looks a bit like a straight line. The other thing that's been done in Australia, and a lot of these studies, migration studies, focus on people that have migrated to Australia. So they've come from places of quite high MS risk, so Scotland, the UK, parts of Europe, and they've migrated to Australia. And what these migration studies show us is that if you migrate from an area of high risk, like those European places, to an area of lower risk, like Australia, then you actually, as a migrant, have a lower risk. You develop the risk of the place that you've moved to. Going the other direction, it's not quite as clear because there haven't been as many studies where people have gone from a low-risk country to a high-risk country. So our evidence is better around this direction. But we also know that it seems from these migration studies that a lot of your risk of developing MS is actually set in place in the first 2 decades of your life. So if you move after the age of about 20, then you're more likely to just retain the risk of where you came from. So it's another clue, like Ellen was saying this morning, there are all these sort of clues about various risk factors, none of which, any one of them is not going to give somebody MS, same with the genetic things, but change the risk and you get enough of those risk factors together and that might be what ends up causing you to develop MS. I only put this in last night. This is the person I originally worked for, Tony McMichael, published this paper in 1997. And he took those data from Aitchison, from the draftees to World War II, and he hypothesised that the latitude gradient that we were seeing was driven through immune suppression that occurred with sun exposure of the skin or through a vitamin D effect. And it was Tony McMichael, when he moved back from London to live in Canberra, that drove a lot of the original research that I was involved in about sun exposure and about vitamin D. So moving on in time, that was 1997. there's a group in Hobart who've become very active. Of course, as you could see from that picture of Australia, MS is much more common MS is more common in Tasmania. In the southern part of New Zealand also has a latitude gradient. So New Zealand's not that much further south. So Hobart's at 43, and I think Invercargill at the bottom of New Zealand's at about 44. So because of the way, the world goes like this, on that picture it was flat, but New Zealand's actually not that far further south. And the population in the south is not so big, so it's hard to be sure of the numbers, but there is a gradient in New Zealand. So this group in Tasmania, so they decided that they would investigate this question about sun exposure. They didn't have vitamin D. They were just trying to investigate this latitude gradient a little bit more. So they ran a case control study, and what I mean by that is that they recruited people who had multiple sclerosis and then people who were the same age and sex who didn't have multiple sclerosis. And they asked them a whole lot of questions, including how much sun did you have earlier in your life, and they actually got sun exposure, how much time in the sun for every year of life and where people had lived from the age of 6. And so what they found was this really, let me explain this funny graph to you first. These are ages. So sun exposure between the ages of 6 and 10, 6 and 15, 6 and 20, and so on. This is what we call an odds ratio, and really the important thing to know about this graph is that if you're below 1, it's lower risk. Okay, so the further you are below 1, the lower is the risk. So what they found is that the people with MS reported lower sun exposure. So higher sun exposure was associated with a lower risk of being a person with MS. But it wasn't just higher sun exposure any time. It was actually this childhood period. So if you had higher sun exposure when you were 6 to 15 years old, or the controls reported higher sun exposure than did the cases. Yeah, so before 6, but they didn't collect data before 6. So you're asking people to self-report how much sun exposure did you have when you were 6. So they felt that 5 and 4, at least once you went to school, you could sort of say, I spent most of my time outside, or, came home from school and I went inside, that sort of thing. But before school, they just didn't collect data. So there's some more evidence on that a little bit further on. So this was a clue, but this was in people with MS. Now, one of the problems with case control studies is that you recruit people with MS, and people with MS are looking for the cause of their disease. So they might report something differently than people without MS just because they have the MS. So it's hard to know in people with MS whether this is just a sort of an error in the measurement of the sun exposure. I'm just going to stop for a minute and just talk about ultraviolet radiation. So when we've got the sun up here, and this is the whole there's a spectrum of radiation, solar radiation that comes from the sun. We have the infrared, which we feel is heat. We have visible light, which we see out there, that's visible light, and you see it as a rainbow. And then the ultraviolet is the bit that has got a little bit, it's past the blue and the purple, and it's a bit shorter wavelength than those things. And we know that ultraviolet radiation causes DNA damage. We're really aware of it in Australia because that DNA damage may go on to cause skin cancer. So the DNA damage is the bit that we've been aware of for a very long time. And this is work that was done by the Tasmanian group again. If you look at melanoma incidence and you compare it to the prevalence of MS, what you find again with that latitude gradient, as you go to sunnier places from Tasmania to Queensland, melanoma increases and it's related to the DNA damage, but MS decreases. Yeah, choices. Yeah, no, it doesn't have to be like that. I'm going to tell you why it doesn't have to be like that. But we now know We've become much more interested in the last 10 years or so in we don't just get DNA damage, but there are benefits to sun exposure because it's our main source of vitamin D. I did all these nice delays and everything so you wouldn't have all these cluttered slides, but sometimes I press the button and nothing happens. So this again is vitamin D production. Vitamin D is only made by the UVB wavelengths, which are mainly get filtered out in the atmosphere actually. So there's only a little bit of the UV at Earth's surface is UVB radiation, and it is very affected by time of day, time of year, and latitude. So it's much more affected by those things than UVA radiation is. So it's only the UVB radiation that makes vitamin D. And this is the vitamin D pathway, and it does look it's a bit complicated and a bit biochemical, but there's a couple of things that we need to have to tell you the rest of the story. So the sun shines on this precursor in the cholesterol pathway, and it makes cholecalciferol, vitamin D, and that's in the skin. And then that cholecalciferol is taken up by a thing called vitamin D binding protein, and I'm going to show you a picture of vitamin D binding protein later, because we're coming to think that actually vitamin D binding protein is really important. And in the circulation, most of our vitamin D is bound really tightly to vitamin D binding protein. That's how it gets around. But this doesn't have any activity, doesn't have any biological activity. It's taken to the liver, and in the liver there are some enzymes that put an extra hydroxy group on it, and it becomes this 25-hydroxy vitamin D3. Now, why do you need to know that? Because when you get your vitamin D measured, that's what they measure. It's not active either. So we're measuring something in the blood which is a precursor to the active compound, and we do that because it hangs around at a reasonable level, at a sort of stable level for several weeks, whereas the active form, this 125-hydroxy vitamin D, has got a very short half-life. It doesn't seem to really be affected so much by sun exposure, and it's in very, very tiny amounts in the body. So what we measure generally is not the active form. We're generally measuring this 25-hydroxy vitamin D. So as the story goes on, we had the 2002, 2003, we had these results from the MS case control study in Tasmania. And then these results are one of my few that are not from Australia, but they're from a huge US military cohort in the US. Now, the one thing that the US has over us is they've got a huge population, and MS is an uncommon disease, so they have the benefit of these huge numbers. So this was mainly young men who entered the US military, and when they enter, they have a medical examination and they have blood taken. And then they have successive medical examinations, and some of them will go on to develop multiple sclerosis, and often when they do, they actually leave the army. So we have these data which are vitamin D levels when these young men were well, and young men, sort of 18 to mid-20s, and then we have them developing MS sometime away in the future. And what they showed was, again, this is the same thing, the odds ratio, so the lower you go, the lower your risk, and this is vitamin D levels along here. And what they found was that people that had very high vitamin D levels, that baseline vitamin D, had a much lower risk of getting multiple sclerosis. So this was the first real evidence about vitamin D, rather than all of the other studies that looked at sun exposure and said, oh, sun exposure, it must be vitamin D. But this was the first real evidence that really was about something happening with vitamin D. So we went on I ran the study called the Ozone study, and what we were trying to do here is get people who were newly diagnosed with MS. So I said to you before, one of the problems is that people that have been diagnosed with MS might recall their sun exposure differently. Certainly once they've been diagnosed with MS, their vitamin D levels will be different. So you can't measure their vitamin D levels and say, look, there's a difference, because it's actually the MS is causing the low vitamin D rather than the low vitamin D is causing the MS. So we recruited people from Brisbane, Newcastle, Geelong and Hobart, so that we got that nice latitude span with clinically isolated syndrome, so this very first indication. Now, what had happened in the US over 20 years is the latitude gradient had disappeared. So they showed a latitude gradient, and then the next wave of data that they collected, the latitude gradient had gone. And what they were suggesting was that there was less sun exposure in the people in the south, and that the incidence of MS had increased to be similar to that in the north. What we found was that our latitude gradient is alive and well. This is a fourfold difference from Brisbane to Hobart, and if you look back on the prevalence one for MS from 1981, it's about a fourfold difference from Brisbane to Hobart. So Australia still has that strong latitude gradient. We also showed in that study that the US military cohort had shown, that once you got into these higher vitamin D levels, you had a decreased risk of having CIS, not just MS, but it was also true of these very early symptoms. And the other thing that we showed was that when we asked about sun exposure, so we measured vitamin D, but we asked about sun exposure, and sun exposure itself was important. And we asked about sun exposure. We asked about, this is a sun damage index, so we asked people, have you ever had a cataract? Yes, no. If you said yes, you got a score of 1, and if you said no, you got a 0. So cataract, pterygium, skin cancer, all the things that are associated with UV. And what we found was, if you had more of those, you had a lower risk of having MS. And we measured, this is a silicone cast, so you mix up some silicone, you put it on the back of the hand and it sets. And when you peel it off, you can see the architecture of the skin. And baby's bottom looks something like this. It's got these fine little lines, very little sun exposure, very little sun damage. When you get sun damage, it starts to look like this. You just get the coarse lines and all the fine lines have gone. So this would be a skin cast score of 1, and this is a 6. And what we found is that the higher the skin cast score, the lower the risk of having MS. So again, a sign that people who had had more sun exposure over their whole lifetime were less likely to develop MS. And when we put those two things together, so we put vitamin D into the equation and we put sun exposure into the equation, both things were still important. So there was something, is it all vitamin D? We know that when you get sun exposure, you get vitamin D, but actually we also know that there are a whole lot of other things that happen in your skin. So when the sun shines on your skin, you don't just get DNA damage and vitamin D. All of these other things are released as well. We ask about sun exposure, but we're really asking about time outdoors. We know that blue light, so up here, affects melatonin, which most people have heard of melatonin these days. We don't really understand a lot about melatonin, but we do know that it also affects the immune system. We know that a whole lot of these things actually affect the immune system, and they affect the immune system in ways quite similar to vitamin D, and in a way that should be beneficial for people with MS. So they specifically damp down that autoimmune reactivity that happens in people with MS. I wanted to briefly mention this because I needn't have bothered now that Alan had talked about it, but he talked about the Antigen Consortium, and the Antigen Consortium was one of the first, it's Australia, New Zealand obviously by the name, it was the first to show that this gene here that converts the 25-hydroxy vitamin D down here to the active form was a risk, increased the risk of MS. So a change in that gene changed people's risk of MS. So again, suggests from Australian data that there is some sort of vitamin D effect. Never quite know what's going to happen when I click this button. I talked to you about the migration studies, and Alan talked, I don't know whether you remember, he had a graph of month of birth in people in the Northern Hemisphere, and people whose mums were pregnant in winter had an increased risk of having MS. So this is exactly the same, but from Southern Hemisphere data, and as you would expect, it's completely switched. And so we find exactly the same thing. If you're pregnant in the winter, then if your mum was pregnant in the winter, then there's an increased risk of having MS. And if she was pregnant in the summer, there's a decreased risk. So there's something about, it's a very early life, something happening in early life increases risk. It doesn't cause MS, but it might add to some of the other things that also might be putting people at risk. I talked to you about 6 to 15, so early life. So we're saying something in utero, we're saying something in early life. We showed that sun exposure right before, in the 3 years prior to the diagnosis, might also be important, could decrease risk. And we've also shown that sun exposure in utero might affect your risk of going from clinically isolated syndrome to developing MS. So it becomes really difficult to study because you've got these effects that are happening in utero, you've got these effects happening in childhood. It's hard to pick out which is the stronger effect, which is the most important. So there's lots of work still to be done in trying to understand these risks. So that's all I want to talk about. I'll come back a little bit to MS risk. But we know that the state of play at the moment is that vitamin D, low vitamin D deficiency does seem to be a risk factor for the development of multiple sclerosis. What vitamin D level? Don't ask me what vitamin D level, because that bit we don't know. We know it in the sort of qualitative terms. We know that it might be important at different stages of life, and it's probably important over your whole life, that those vitamin D levels are maintained at some sort of reasonable level. But we also know that sun exposure itself is probably important. So sun exposure is working through a vitamin D pathway, but maybe there are other pathways that sun exposure itself is important. And why does that matter? Because if it's all a vitamin D effect, you can stay out of the sun and have a vitamin D supplement. But if there is some additional benefit from sun exposure, then actually you need to go outside and get a little bit of sun exposure. You'll get your vitamin D and you'll get the other things. So I'll move on now just briefly to talk about a lot of people here have MS. So what about vitamin D and sun exposure in disease progression and disease activity? We know lots of studies show us that people with more severe MS, with worse disability in MS, have lower vitamin D levels. The challenge is which came first, and can be just really hard to work out. So people with more active disease are more likely to, and more disabled, are more likely to stay inside, and they're more likely to have low vitamin D levels. So the way that we deal with that, I'll come to that. So there's some studies, there's the studies from Hobart that show that there may be an interaction with vitamin D and some of the therapies, and the one that they've looked at for the moment is interferon beta. I gave a talk to the ACTMS Society last week, and they said to me, what about the newer drugs? We haven't got that yet because these studies all take so long to do and to get the numbers on the newer drugs. But what this group found was that if you had higher vitamin D levels, you got a better effect from interferon beta, and there's been some additional work. Interferon might be working through a vitamin D pathway, or vitamin D might be working through an interferon pathway. So things still to be worked out. And again, we're still not sure about this. There are some studies in people with MS that are also showing it's not just vitamin D effects, but that there are sun exposure. And in some of the studies, sun exposure has a stronger link than vitamin D does to various outcomes like changes on MRIs. But when you have sun exposure, you're not having sun exposure without vitamin D. When you have sun exposure, you're getting the whole lot. So it's quite hard to separate those out. What we do know in the clinical trials for MS treatment, so these are people with MS that are given different doses of vitamin D supplementation or placebo, and there've been lots of them. There's some of them there. We see, even when they get people up to very high vitamin D levels, we see that the immune changes might look better and the MRI might look better, but actually it doesn't seem to make any difference to the disease. There's the number of relapses and the progression of disability, we're not seeing a striking difference in those things. Some of the studies show a little bit of difference, some of them are a little bit inconsistent, but it's not, well, fantastic, this is the miracle cure. So moving on, I talk to you about comorbidity, or in people with MS, well-being. The group that talked before me talked about falls and balance. People with MS are at greater risk of falls and fractures for all of those things that we heard in the last session. Vitamin D, its primary role in the body is to maintain calcium homeostasis and bone health, and it's really important for muscles. So it makes really good sense to make sure that your vitamin D levels are at least at a level where you're preserving your bone health and you're giving your muscles your very best shot. So that would be at least more than 50 nanomoles per litre. We do know that sort of thing for bone health. People with MS are at greater risk of depression, and there's some recent studies that show that sun exposure and some other studies that show that vitamin D supplementation can decrease the risk of depression, so another good reason to keep your vitamin D levels up and have some sun exposure. And similarly for fatigue, the next session, higher sun exposure and vitamin D supplementation, both associated with less fatigue. Again, sometimes it's hard to work out the cause and effect, which came first, but for the moment it seems sensible to actually maintain vitamin D levels and get some sun exposure. Is more always better? You saw in that graph I showed you from the US military cohort and from our studies that you really started to get a significant beneficial effect when the vitamin D levels were up around sort of 80 to 100. But there are some studies starting to come out which suggest that you just don't keep getting benefit as you go higher. So you get a decrease, this is mortality, and this is risk of prostate cancer. We don't have these graphs for multiple sclerosis, but there's a lot of this, like happens with any natural sort of exposure to an environmental factor. A little bit of sun exposure is good, a lot of sun exposure is bad. A little bit of stress is good, a lot of stress is bad. And it's the same with vitamin D. So you get benefit up to a point, and then actually it starts to be not so good for you. So there's a study paper that just came out today by somebody who managed to get people's vitamin D levels over 400 nanomoles per litre. Well, there's no benefit from 400, there's no evidence of any benefit from getting levels that high. Think about being in the sort of 50 to 100 range. So there's a lot we don't know, we're still working on it. These things I've talked about. I think vitamin D works hand in hand with calcium, so you need to make sure that you're getting dietary calcium. So get some sun when you can, several times a day. Perth's a great place to do it. It doesn't need, vitamin D is made really, really quickly, so you only need 5 to 10 minutes in summer in Perth. You just need to, I always say to people, go and get your coffee at lunchtime. Go for a little bit of a walk, and a bit longer in winter. I mean, at least in Perth you've got these beautiful sort of sunny days, and in the middle of the day is the best time in winter to get your vitamin D. So this is some of the MS research that we're doing in Australia, and I can see that this is one I should have put on a black background because it's very hard to see. We ran the Ozone study, which was around clinically isolated syndrome. We're following the people that had CIS in that study through these other studies. So some of them, about 70% of them, have already developed MS after 5 years, and we're now following them out to 10 years. And then some of these vitamin D supplementation trials, not so much happening in Australia, but we have these absolutely landmark, fantastic studies, the Prevan study and what Alan calls the FOCUS study, but I call the FOCUS study, but it's the same study. Which is happening here in WA. And these really are world firsts happening in Australia, which is fantastic. So the aim is to prevent the development of MS. So the first one is the Prevan study, and this is a study of vitamin D supplementation. So it's a placebo trial, so people with clinically isolated, we'll get to it eventually. So 240 adults living in Australia and New Zealand who've had a clinically isolated syndrome, they come into the study, they're randomised to receive placebo or 2 different doses of vitamin D, and then they're followed in time for 2 years to see whether that vitamin D supplementation changes the number of them who go on to develop MS, and whether we can actually, even after somebody's had that high-risk event, CIS, we can stop them going on to develop MS. And I think Prevans is got a large proportion of its funding actually comes from MSWA, and it really is, the world is looking to the study to see what the answer is here. And then we have the PHOSIS study, which is being run here in WA, and again, this is just an amazing thing to have here. Prue Hart actually runs that study and works with Alan and David Nolan and Bill Carroll and various others. And it's the same group of people as Prevans, so people with clinically isolated syndrome, but instead of giving them vitamin D supplementation, what we give them is sun exposure. So it's sun exposure in a sun booth thing like they use for psoriasis, and people are randomised to just have their normal treatment by their neurologist or have this UVB phototherapy. And the really nice thing, I think, is that we have the Prevans study and the PHOSIS study going side by side, the same groups of people, and we are going to be able to tease out how much of an effect, if any, is vitamin D supplementation effect, and how much, if any, is the sun exposure. And it will just incredibly help us to give the right messages to people who are at high risk of developing MS. So then I also have some funding from MSWA, thank you very much, and it's to explore vitamin D in more depth. So this is on blood samples from the Ozimmune study. So these are people who had a clinically isolated syndrome and the matched controls that were the same age and sex but didn't have any evidence of demyelination. And what we're going to do is we're going to drill right down into not just the 25-hydroxyvitamin D, but to start to look at the various other types of vitamin D. So there's the active form. Now we know that from the Antigen study that the gene that's important to MS is the one that turns 25-hydroxyvitamin D to 125-hydroxyvitamin D. So what will we see in the blood of these people who have had a clinically isolated syndrome? What will we see in terms of the active form and the breakdown form? There's lots of interest in this thing called, it's a different, the molecule is different, it's 25-hydroxyvitamin D, but it's been turned around in a way, and there's some interest now in whether if you have a different amount of that can change your risk of MS. So we've only just been able to measure some of these things. And so this is sort of new work trying to drill down into what should we really be looking at and what can this tell us about risk of MS in these people. So it might help to explain some of the differences that we see where we're not seeing the effect in the vitamin D supplementation trials, maybe because we're supplementing with the wrong type of vitamin D. And this funny picture here is actually vitamin D binding protein. There was a really interesting study from the US a year ago, or 15 months ago now, that showed that it wasn't the 25-hydroxyvitamin D, which is typically mainly bound to this vitamin D binding protein, which was important to disease risk. You got a much stronger effect if you looked at the 1 or 2% that wasn't bound to the vitamin D binding protein. So we're going to be looking at that as well to see whether that's actually a better measure. UWA has one of the best vitamin D assays in the world, and we have this fantastic young man, Michael Clark, at UWA, who is developing all these the ability to look at all these different metabolites that actually nobody else in the world is yet able to do. So we're being able to do, funded by MSWA, a suite of tests around vitamin D metabolites, which we really wouldn't be able to do anywhere else. So that's work that's just starting, and we're really looking forward to seeing what those results show. That's all I have to say. Thank you. Questions? All right, thank you. So ozone depletion, so the ozone depletion is important because ozone's the main thing that filters out the UVB, and we know that the UVB is really, really important. But ozone depletion, if you look at where the ozone hole is, it's really asymmetric, and it actually doesn't come over Australia at all. It comes over Antarctica and the bottom of South America. So there's only been, it's been very difficult to show. Ozone has definitely been depleted, but it probably has only had very marginal effects on UV radiation over the places where most people live. We are getting less sun exposure. If you look at the very few studies that have been done that looked at vitamin D levels over time, they've gone down over time. If you look at our sun exposure over time, our sun exposure has gone down over time, which is great because melanoma incidence is going down, particularly in younger age groups, and that's fantastic because slip-slop-slap is working. We are getting less sun exposure. Some of that's slip-slop-slap, some of that's computers and office jobs. I don't know about other people, but you arrive when it's barely light and you leave when it's dark. And if you don't go out in the middle of the day, it doesn't matter how sunny it is out there because you're actually not getting any of it. I don't think it is. I mean, I think it's actually, we work really closely with the cancer councils, and because vitamin D is made so quickly, going out and sunburning is the absolute wrong way of getting your vitamin D. Don't let anybody use as an excuse. These young people, they are not to use an excuse, I'm getting my vitamin D. When you stay out in the sun for long periods of time, the vitamin D actually gets broken down into inactive products that stay in your skin. So what you need to do is to go out for short periods of time, 5 to 10 minutes in the summertime. Go out a couple of times a day if you feel like it. Go out as many days of the week and bear as much skin as you can. The amount of skin you bear is really, really important because you can get a low dose to all of the cells that are exposed. They don't increase their skin cancer risk because they're only getting a low dose of UV, but every single one of them is generating vitamin D. So short periods of time, lots of skin exposed. So sunscreen, if it's correctly applied, I will tell you, sunscreen, if it's correctly applied, it doesn't stop vitamin D production, but it does decrease the vitamin D production. When I say properly applied, it's very thick. So I remember Terry Slevin from the Cancer Council here reading something that he had written. So a teaspoon of sunscreen for an arm. So try it. It's disgusting because I tried it. It's completely disgusting. Once you put the teaspoon on, you'll need to go and get the towel to wipe it off again because it's really... So nobody puts sunscreen on like that. So actually sunscreen doesn't make a big difference to our vitamin D. But it does protect us against skin cancer. So the supplements of vitamin D will get your vitamin D level up. So in terms of whatever the benefits are of the vitamin D part of sun exposure, supplements will definitely help with that. If you've got really, really low levels of vitamin D, then absolutely take supplements to get yourself up because we do know that vitamin D deficiency is associated with weaker bones and more risk of falls and those other things that I talked about. So, you must get your vitamin D levels up into that normal range, which is more than 50, and possibly for people with MS, it needs to be more up around 70. Yep. So it seems to be the best correlation is with the late first trimester. of pregnancy. And so that graph I showed, if you're welcome to have the slides. What they did in that paper is they mapped out month of birth, and then they overlaid UV radiation at the end of the first trimester, and you'll see the two lines just go like this together. So they're really tightly linked. And presumably that's for brain development, immune system development. I don't know exactly which is the key thing that is happening then, but there is something about that late first trimester which seems to be important.
Okay, thanks, Robyn. All those questions certainly tell us. Those questions certainly tell us the level of interest in your topic. And, we look for hope and we think about, our children, our grandchildren and so on. And it seems that perhaps continuing to get kids out and playing in the sun when they're little at that 6 years of age is a much better thing than having them quietly watching the TV or the Xbox or some of the other indoor activities. So thank you for that, and we wish you well as you continue with those studies, because we'll be looking for those results. Okay, if we can have the next lot of slides. Fatigue in MS. So my hat now is Manager of Occupational Therapy. Fatigue is a very common subject for people with MS, up there in one of the most troublesome symptoms. So I want to give just a bit of an overview today for you, and hopefully there'll be a few new things and some strategies that you can take away with you. Fatigue doesn't affect only MS. It's common in many other chronic conditions, but you don't have to have a condition either to have experienced fatigue. Not wanting to say that fatigue for everybody is the same though, and we will see that fatigue in MS can be more troublesome than for usual. So we'll have a look at what is fatigue, we'll have a look at some of those causes, bit of intervention, and talk about the value of rest. Basically, to define fatigue, everybody might have their own way of defining it, but we could call it as a weariness caused by hard work. So if you've been working in the garden for 3 or 4 hours, you could feel weary after that, unless you're really fit. Temporary reduction in the capacity to respond to stimuli on part of the cells or organs after excessive activity. So this will be where your threshold is for your muscle capacity to continue firing and working, goes down the more you work. There could be a decrease in the ability to do work due to the tiring effects of recent previous work, and might otherwise simply be just a lack of energy. Anyone have those fatigued days? You can wake up feeling great and fatigue quickly, or you can wake up just feeling that today is just not the same energy sort of day. When we look at fatigue in MS, most people will experience fatigue at some times, but in people with MS, it can experience it sooner, and recovery usually takes a little bit longer. People come up with their own analogy to describe that fatigue, and that can be really useful for helping family and others to understand what that fatigue is like for you. So someone had once described it as you get a pile of mulch dumped on your lawn, and you get your wheelbarrow and your spade and you shift it because they dumped it on the lawn and you want it on the driveway. So you move it over onto your driveway, and then you realise, no, you can't have it on your driveway, and you have to move it all back again. That's just total exhaustion. Sometimes even just thinking of activity can be induce a feel of exhaustion or tiredness for people. When we put fatigue into focus, it's estimated that between 70 and 90% of people with MS experience fatigue. Mostly these will be on scales that are self-rating. So some people, they might underplay or not rate their fatigue so much as somebody else, or it might be that by the end of the day there's an increased level of fatigue, but it doesn't necessarily continue from the moment of waking to the moment of going to sleep. I kind of figure that even if you have a little bit of fatigue, it impacts on your routines hugely. So if you shorten your day by 1 hour because of fatigue, whether that means the things you're doing are just done a little bit slower because you're a bit fatigued, but if your day is shortened by 1 hour, that is 7 hours in 1 week. So fatigue can have a huge impact on lifestyles. It's a major reason for people leaving paid employment, and we know the socio-economic changes for people with MS over the course of their condition. It can lead to decrease of helpful roles in the home. So suddenly what you can't do, what you used to do, others in the home may need to step up with, and so that dependency on others to continue to run the home can be present. Often fatigue is a hidden symptom, and So unless somebody's totally exhausted and you can see it in their face, you may have a level of exhaustion that nobody else can see. And partly you might think that it should be obvious to everybody else, only when we recognise that there are some symptoms that are hidden, fatigue is certainly one of those. Maybe up to a level 4 out of 10, you might say it's still not really obvious to others. By the time it hits a 7 or 8 out of 10, they're saying, you're exhausted, go and sit down. Because it's hidden, and then there's the language that we use around it. Some people say, well, I don't want to complain about being fatigued all the time. Nobody wants to hear about my being fatigued all the time. And so they can feel isolated because of that level of fatigue. What we can do from an occupational therapy input is learn and teach some strategies around ways to manage the energy levels that can improve quality of life. So if we have a bit of a look at a fatigue cycle, so starting there at fatigue, somebody might experience fatigue. Because they're fatigued, it leads on to having decreased activity. Because they're not doing as much as they were doing, I mean, we tend to feel good by what we do. At the end of the day, oh, what have I done? And we tick it off. We're very activity-focused society. We mothers will wear with a badge of honour how they work full-time and still get their kids off to all of their activities after school, being the super mum. And so when there's a decrease in activity, people can then feel that there's a sense of inadequacy, and that can lead into stress, and stress feeds into that whole fatigue cycle. So we want to be able to identify it and say that if we can break this cycle, not only at the entry point of fatigue that I've gone in on, but we could break that cycle at any point. So if we were to deal with the stress, then we could help to perhaps reduce some of the fatigue that's experienced. Fatigue, on the whole, might not be a problem for most, but it can become a problem, and whether that's the problem experienced emotionally or whether that's the problem that's experienced by the level of activities that you are not able to continue with, then it's useful to talk to somebody about that experience of fatigue. We have a couple of self-questionnaires to promote the self-awareness, and one of those is the fatigue severity scale, which is a nice little scale of about 9 questions, and it asks you to rate things on a scale of 1 to 7, with strong disagreement through to strong agreement. 2 of those questions. My motivation is lower when fatigued. Rate that between 1 and 7. Number 2, exercise brings on my fatigue. So if anyone, some of you might have seen that scale and used that scale. If you haven't and you're interested, we've got some out the back, and Pam's got them somewhere for me, so you're welcome to have a look at that one. So these scales often help us to understand also the sorts of things that are what your fatigue experience is, and how distressing that fatigue can be to you. When we look at fatigue, it may not just be a lack of energy. Fatigue is common in many disorders. What we're wanting to do is say, what are some of the things that you can control that could then help you control the fatigue that you experience? One of the things that we do in our fatigue management program is we don't call it, in fact it was Professor Tanya Packer, she says we don't call it fatigue, we want to call it energy management. And I think you'd agree with me, just the word fatigue kind of leaves you feeling lethargic, whereas if we could call it energy management, or how many jelly beans do you have in your jar today, we can conjure up a different picture. And we need to perhaps have a look at a little bit at the language that we use when we're going through the day, because that language can create images, and those images can help energise or deplete our energies further. Some of the causes for fatigue, we've covered stress being one of those causes. So there may be work stress, it may be ongoing stress, or it may be temporary stress. There may be the demands of what's required in the home or in the workplace. There's the family commitments. One of the things we've got passionate over in the last couple of years has been sleep quality. So if you're sleeping more than sort of 9 hours a day and still feeling exhausted, then that quality of sleep is not good, and that therefore sleep is a problem. Adults should get between 7.5 and 8.5 hours of sleep a night, and so getting 9 or more hours is really too many. You look at people with sleep apnea, we have a lot of information around that now. So, there's simply the quality of the sleep through the night is not replenishing. Getting more sleep is not the answer when you're already getting a lot of sleep that's not refreshing. Not getting enough sleep is going to feed into that problem of feeling fatigued in the morning. So ask your friends, ask your family, if you don't get enough sleep at night, how do you feel the following day? Diet will impact on fatigue. So if your bodies are under stress from poor nutrition or inadequate nutritional intake, it will come out as fatigue. The physical activity is important, keeping yourself fit, keeping yourself as active as possible. And of course, medications can also impact on how our energy levels are the following day. There's other effects on fatigue, including thinking and memory. So if you're really tired or you have that level of fatigue, you may not take things in quite so well. You may not process information quite so quick. Your mood can be impacted if you're feeling fatigued, and that can strain on relationships. Your self-esteem, which is kind of that view of self and feeling inadequate. And then there's a reduction in enjoyable activities. What we often find is that when people get, they have a level of fatigue and they'll maintain the routines that they say, I'll keep my work going. Work's the most important thing. And before long, they find that they go to work and they come home and they sleep. And they get up the following day and they go to work and they come home and they sleep. And there's a depletion of the pleasurable activities because they haven't been able to keep up with that. And so what we're encouraging is for people to have a look at the enjoyable activities, because if we say, what did you do what's a highlight for you in the last 12 months? It's going to be a pleasurable activity rather than a work task that's the thing that will be in your memory. And the thing that energises you again or puts jelly beans into your jar will be those things that have been happy and fun, not work task and work focused. MS fatigue also has what we call a nerve fibre fatigue. So the nerve fibres in the brain fatigue and they don't conduct as well, they don't send those messages down as well. And the other is a lassitude, which is just this sudden overwhelming tiredness that can sort of hit from left field. These two types of fatigue you can't push through. So, when you hear people saying, I just pushed through my fatigue and you just got to get doing what you've got to do, it doesn't apply in MS. And we're really advocates for having regular rest, because that is the way to restore the body and to let the body be better equipped to continue for the tasks that you want it to do. Just want to run through some of those causes then, and saying that if you may not be able to control the lassitude or the nerve fibre fatigue, but you may be able to control some other things in your life that impact on fatigue. So this is a way that you can have some control over your energy levels. So if physical fitness is an issue, certainly working in with physios. OTs need to work in with physios on this one of fatigue management, because if you are not that fit, your body is going to tire quickly. That's the bottom line. And clearly physios like to work you pretty hard, but that way you get the results. So if physical fitness is the issue for you, movement is good. Keep moving, build physical capacity, get to physio, join a class, join a gym. There is a daily recommended dose of exercise. What do they tell us on TV? Find 30. Find 30 that gets your heart pumping a little bit higher than normal, that raises your blood pressure, it raises your body temperature. Exercise is good for everybody. Talked a little bit already on the sleep. So when we look at sleep being a 24-hour cycle, not an 8-hour cycle, it's also the things that we do through the day. So excessive napping and resting through the day does not help your body prepare for the sleep cycle at night, and that can contribute to poor sleep through the night. In the USA, up to 1/3 of adults at any one time are reporting inadequate sleep. So we're not talking about this as being a problem just with MS. It's really a whole problem across society. That increased risk of car accidents, about 100,000 I think it was per month, were reportedly because of sleeping at the wheel. To improve sleep quality, just adopt good hygiene sleep practices. And this is where, when your kids are little, you say, okay, toilet, teeth and bed, or toilet, teeth, go, you smile, I do too. I think, yes, I remember doing that with my kids. Toilet, teeth, bed, we'll read a book, everything slows down for the day, it prepares them for sleeping. But what do we tend to do as adults? In fact, there was a joke that went around, the husband says, oh, I'm going off to bed now, so he gets up from the chair and he goes off to bed. So She says, oh, I think I'll go to bed now. And she gets up and goes and finishes doing the dishes, sweeps the kitchen and prepares the kids' lunches, and then she goes to bed. So sometimes toward the end of the night, and we're thinking, oh, what didn't I get done today? Our sleep routine has to be one that prepares our body for sleep. And the bedroom is the best place for two activities. And one is sleep, and the other is not TV or reading. It's intimacy. And then the other activities are best done out of the bedroom, because when you approach the bedroom and your sleep time, your body and your mind are gearing for that. So the things that we did with our kids were very useful to prepare them to go to sleep, and a lot of people that our OT who is involved with sleep, she finds is that they've adopted some poor practices around sleep hygiene. Also that daylight, getting the sunlight in the morning, very good for turning off the melatonin. The melatonin is necessary to induce sleepiness, so we want to switch it off in the morning, and as it starts to get dark later in the day, that's when it's preparing to come on again. So there's ways that you can improve your sleep quality. It may be if you're dealing with pain or the bladder has you up and down all night, speak to our nurses, speak to a health professional, because you should not be needing to get up multiple times through the night. And you should feel refreshed in the morning from your sleep. That's what a sleep is for. We would invite people into our fatigue management program and would have a look at sort of the activities that they do through the day and so on, but sleep has now become our number one thing that we will look at first. If adults in general are poor sleepers and feeling tired, then that can be one area that you get biggest first impact on fatigue. Changing sleep habits though can take a little bit of time, up to 6 weeks. So, if you say, oh, this technique didn't work, I'll go back to my old habits, and you haven't given it enough time, that's why it's great to chat to a health professional and get the support and get good information. Nutrition, we want to function optimally, so it's lovely to have a lovely spread of a range of foods, out for the morning tea. Not going to bed with too much food in your stomach, thinking about, the alcohol. Some people take alcohol, so it really helps me to get off to sleep, accepting that it doesn't maintain a good sleep pattern through the night. So although you might get off to sleep, it doesn't keep you asleep. So watch out for things like the caffeine, the alcohol and the smoking. Drink plenty of water because your bodies need it. Australian nutritional recommendations are saying 6 to 8 cups of water a day. Don't substitute those with coffee and tea. Their dietary recommendations, 5 and 2. 5 veg, 2 fruit. How many actually get 5 and 2 regularly? Some, but not a lot. So there's some things that we know are good for us and we don't do. And even if we just were to change some of our lifestyle routines based on what we know, we might find that we feel a lot healthier. Sickness can impact on fatigue. So that raising of the core body temperature when there's an infection, that can also lead to sleep difficulties. Thermal dysregulation through the night time can lead to sleep difficulties. Common infections like a common cold, a person with MS might feel that just drags on a little bit longer and is a little bit harder to get over. So if you have things that you need to keep going and doing, you might want to seek some medical treatment, earlier to get on top of that. There's other medical disorders that we need to consider with fatigue, and I think mostly it's pretty well known now, but, making sure you've got enough iron, get the blood tests. Maybe, if it's thyroid problems, get the blood test, because there's no amount of sleep or exercise or good food is going to replace some of those, and improve some of those conditions. The treatment options, I'm just going to whiz past some of the depression. I'm saying about thinking about your language and, the pictures and things. So it's like, you can go from this to this, and maybe some of the imagery as well can help you to rephrase what that fatigue or what those energy levels look like for you. I think one of the important things, or just 3 key strategies for us then, might be the importance of rest. Examine the activities that you do and review the structure of your day or week. So just a quick word on rest. So it's a very small slide there, you probably can't read all that. But we know that when you're exhausted, your body needs rest. There's no way around that one. And so the idea that comes out of the fatigue management that was well researched is saying that if you rest before you become exhausted, you will need less rest to get going again. In other words, rest before becoming fatigued. You might want to look out and say, what are the early signs that I'm becoming fatigued? And it may be that you just get a little bit more irritable, or you just notice your thinking slows down a little bit. What are those early signs for you? And it may be sufficient to take 5 minutes every hour is all you need, just to shut off and then get going again. Turn some nice relaxing music on, and when that's come, when that's over, you can get on with the rest of the day, or get on for the next hour before you take another 5 minutes break. We have people who will squeeze in as much activity as they can into the morning because they know at 12 o'clock they're going to hit the wall. And really what they've done is they've eaten all their jelly beans in the jar, and they have no energy left for the afternoon. So changing habits can take time, but we've seen some really good results for people doing that. Short, frequent rest throughout the day is a matter of trial and error, and being willing to trial different ways to rest and how long you rest. So it may be that you can just sit down quietly in a chair that's well supported, and that 5 minutes is all you need. Or it may be that you want to go and lay on the bed for 5 or 10 minutes. It may be you want to take a 20-minute rest and put your feet up. But what type of rest and how long is a matter of trial and error. We just know that taking regular rest helps to prevent you from feeling as exhausted as you may otherwise do by the end of the day. You can also pace your activities so that those activities that are, some activities are more energy draining than others. Going grocery shopping. You don't go grocery shopping if you feel exhausted. Pushing the vacuum cleaner and doing housework, they're really exhausting activities. But then there's other activities that you need to do that won't be so exhausting. So pacing the activities throughout the day or throughout the week is one way to still get done everything that you want to do without hitting the wall and having exhaustion. You can also do things like planning your day, so planning your meals. If you know you've got a busy day, have an easy meal, or have a meal that's already been prepared, pull it out the freezer, have it partially prepared the day before, so that you're not having a busy day plus usual energy demanding activities at the end of that same day. Some people do their grocery shopping, come in, bar the fridge and freezer stuff, put those away, and then just sit down, take 10 minutes, and then start to put the shopping away. And breaking tasks up like that we've seen people just be able to avoid hitting that wall. I think really in summary, it's just to say that as far as fatigue goes, you're not alone, but that it can be managed. Often we thought, oh, well, this is fatigue and I just can't control it, and it just controls me. And that's not the case. You can manage it. Partly you need to get to know yourself and take time to think about some of the choices that you make and what the balance is in your week. Communicate with others, network with others. Please come have a chat with OT, because we have quite a lot of information that we'd love to share with you that I could not put into a half-hour segment. And that will be it for our morning. Thank you. Is there any questions on that? I realise we've gone to the 12:30, yes? And has it worked for you? Thank you. I'll summarise a half hour into 30 seconds, then do a little, rest a little. Advice from Dr. Kermode. Thank you. Thank you for your attendance here today. I hope that you found that really useful for you. And if there's any information that you're wanting, we're going to try and get a copy of the slides from Dr. Kermode. Someone was asking for those. So if there's any of that sort of information, please see one of our staff so that we can